Good afternoon. This is Group 1 for the wind turbine project. The group includes Adrian Buendia, John Giuliano, Sednit Jean, Carlos Mancada, Juliet Perez, Veronica Poitamani, and Daniel Ramirez.
So for this 3MT, first we are going to introduce our wind turbine project, talk a little bit about our design intent, discuss any potential scale-up opportunities in the future, and as well as our team's recommendations as to the wind turbine dimensions. So in this wind turbine project, our team applied our knowledge of design, manufacturing, process selection, quality engineering, using SolidWorks and Minitab. Additive manufacturing is the process used for making 3D solid objects by adding material layer upon layer. Our team used fused deposition modeling. And then we used SolidWorks flow simulation to test 8 different designs of the wind turbine and their ability to produce fan speed. And then we utilized additive manufacturing to produce the wind turbine model.
For the design intent, the design is served to produce fan speed while minimizing factors which contribute to waste. The turbine should be less than 120 millimeters in diameter or 60 millimeters for each blade and have hub dimensions that are illustrated in this bottom left picture. The team utilized Minitab to conduct 8 different experiments, which gave us a regression equation to maximize the 4 significant factors to maximize our thrust speed or our fan speed. These 4 factors included width of the blade, angle of the blade, the number of blades, and the thickness of the blade. And our Minitab experiment can be seen in this middle picture with the min and max width, thickness, angle, and number of blades that we used to conduct our experiment. And then in this bottom right picture is our final wind turbine. For scale-up opportunities, a life-size wind turbine is too large currently for a 3D printer, but the 3D printer has advantages for rapid prototyping. If the team were to use this for a real-life production, the team would use a vacuum resin infusion to scale up the production, as this is what's used to produce boats. And as you see, a vacuum pulls the resin through the mold, and then you just take the mold out and you have your part. The recommendations, the essential components for the product is a 40-degree blade angle with 6 blades, 14 millimeter width, and 1 millimeter thickness of the blades. The team focused on the width and angle of the blades, the number of the blades, and the thickness, because this is what the regression model in our Minitab analysis gave us. And then for the 2 analyses that we did, it was a combination of first designing the experiment in Minitab and then building these parts in SolidWorks and then running a flow simulation in SolidWorks as well. And that is it.